Hello, and welcome to Algebra Unit 2, Concept 5, Lesson 2. Today, scholars will understand discrete and continuous functions. As a reminder, you should be completing your notes as we go through this video. So let's look at this situation. The Library of Congress in Washington, D.C. is considered the largest library in the world. They often receive boxes of books to be added to their collection. Since books can be quite heavy, they aren't shipped in big boxes. If, on average, each box contains about 8 books, how many books are received by the library in 6 boxes, 10 boxes, or n boxes? So we're going to use a table, a graph, and an equation. So let's start by doing this with a table. So here's our table. This is the number of boxes, n boxes, and this is the number of books. So in one box, they have 6 books. So in there's 8 books per box. So in one box, they would have 8 books. In 6 boxes, they would have 6 times 8, which is 48. In 10 boxes, they would have 80. So let's think about what that means. So there's 8 books per box. So we've done a table. Let's think about what a graph of this would look like. So a graph would say, okay, in one box there would be 8 books. In 6 boxes there would be 48 books. Put that way up here. And there'd be dots in between for each box of books, right? But it would be dots because you can't get 1.5 boxes of books. Does that make sense? So then let's talk about our equation. Our equation would be number of books equals 8 times the number of boxes, n. Does that make sense to everyone, okay? Books equals 8 times the number of boxes. And that's what our graph would look like. So what's the domain of this function? Remember, domain is our input. What's our input? Input here is the number of boxes, right? Because that's what we're trying to find out, is how many books do they receive per box. And then our output, or our range, would be the number of books. So our domain is the number of boxes. So many of the books in the Library of Congress are electronic. If about 13 ebooks can be downloaded onto the computer each hour, how many ebooks can be added to the library in 3 hours, 5 hours, or n hours, assuming that the computer memory is unlimited? So again, we're using a table. So let's start with our table. So our table, this is hours, n hours, and then we have number of books. So in 1 hour, it says we can download 13 ebooks. So that in 3 hours, we could download how many ebooks? We could download 39 ebooks. In 5 hours, we could download 5 times 13, gives me 65 books. Then we were asked to make a graph. So our graph of this one would be like this. We could check at any possible time. 1 hour, 3 hours, 5 hours, but we can check in between. And then finally, we need our equation. So our equation is each hour we could download 13 books. So the number of books equals 13 times the number of hours. So what was the domain of this function? What's our input? Well, our input is the number of hours. Okay, so we all know my handwriting's not great. Number of hours is our input. Number domain is our input. So, let's look at this one now. The librarians work to keep the library orderly and put books back in their proper places after they've been used. If a librarian can sort and shelve 3 books a minute, how many books does the librarian take care of in 3 hours, 5 hours, or n hours? Okay, so once again, we are using a table. N hours, and this is books. So, she can do 3 books in a minute. So, in 1 hour, an hour has 60 minutes. 60 times 3 gives me 180 books reshelved. In 3 hours, she could have how long? How many? 3 times 180 is 540. In 5 hours, she could do 900. So then how many can she do in n hours? Well, each hour she does 180 books. So the number of books equals 180 times n. There's our equation. What would a graph of this look like? What would a graph of this look like? Well, it's going to be a proportional relationship of 0, 0, and it's going to be 180 per. But is it actually a line? Or is it going to be dots? Can we check it at any time? Yeah? So, let's think about this. Discrete or continuous? That's the big thing here. So, would it make sense in any of these situations for there to be a time when 32.5 books have been shipped, downloaded to the computer, or placed on a shelf? Well, no. It doesn't. Because, well, you can say sort of. For ebooks, you could have half of it downloaded, right? You can have for ebooks, but not for books that are placed on a shelf, and not for the number of books that are shipped. Which of these situations, in problems 1 through 3, those first 3, present a discrete function? So a discrete function, you could use any input value. Or sorry, discrete function only has specific input values. Try that again. So discrete functions have only certain input values. I get a certain number of boxes of books. That's discrete. Continuous can be evaluated at any point. Any input value. Within range. Obviously, we don't have negative time and things like that. So we're talking about continuous function. Continuous function would be how many books we reshelved. Shelved or downloaded. Because we might have part of a book downloaded. And we can check that at any given time. I can check at 1.25 hours. I can check at 1.25 hours how many books they've reshelved. Okay, so this has to do with your input values. Discrete means only certain input values have a meaning. I can't get 2.5 boxes delivered. Continuous means we evaluate at any input value. So let's look at this next one, cutting paper. A giant piece of paper is cut into 3 equal pieces, and then each of those is cut into 3 equal pieces, and so forth. How many papers will there be after a round of 10 cuts, 20 cuts, and cuts? Okay, so we're going to use, once again, a table. Okay, so this is cuts, and this could be pieces. So after one cut, there's 3 pieces. After 2 cuts, we can see right here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. So let's talk about an equation. This is not going to be linear. If you notice after the next one, 3, I'd have 27 pieces. This has a common ratio. So this would be an exponential function. So f of x, or f of c, would equal 3 to the x power. Okay? So what's the domain here? What is our input? Our input is number of cuts. Would it make sense to look for the number of pieces after 5.2 cuts? No. Because we don't do 5.2. We either cut them into 5 separate rounds or we don't. And would it make sense to look for the number of cuts it takes to make 53.6 pieces of paper? No. You cannot have 0.6 papers. You could have a smaller paper, but it still wouldn't be 0.6. It would be its own piece of paper. Finally, let's look at this one, medicine. Medicine taken by a patient breaks down in the patient's bloodstream and dissipates out of the patient's system. Suppose a dose of 60 milligrams of antiparasite medicine is given to a dog, and the medicine breaks down such that 20% of the medicine becomes ineffective every hour. How much of the 60 milligram dose is still active after 3 hours, after 4.25 hours, or after n hours? So we're going to do our table. So at hour 0, he has 60%. Each hour, he's going to lose 20%. So after 1 hour, he loses 20%, which is going to be 12 milligrams, so he'll be at 48 milligrams. After 3 hours, he'll be at 30.72, and so on and so forth. We'll keep multiplying by 0.8. So we can write the equation for this as f of x equals 60 times 0.8 to the x power. What is the domain of this function? The domain is time. Would it make sense to look for the amount of active medicine at 3.8 hours? Yes. We could figure that out. Time is continuous. So that's the thing to remember. Time is continuous. Would it make sense to look for when there's 35 milligrams of medicine? Yes. Medicine amount is also continuous. We can have partial milligrams. So, let's follow this. What does it mean to be discrete or continuous? What needs to be considered when we're looking at a situation or context and deciding if it's discrete or continuous? So we need to know, can it be evaluated at any point? Can I check it at any point? And the difference in the presentations, a table and an equation are like the exact same if they're discrete or continuous. The only place you can see a difference is the graph. If it's continuous, it will look like this. This is continuous. If it is discrete, it will be a series of points. Discrete graphs are simply a series of points. Okay, good luck with your work for this.